Hi, my name is Seth Arkwright, and I'm an aerospace systems engineering student graduating at the University of Akron. My project is the design of an active control pressure regulator for use in a rocket. This project is a complete project going from design through build and test, and is focused specifically on control theory and fluid dynamics within the realm of aerospace engineering. The problem we set out to solve with this project was the use of mechanical regulators on our test stand and other teams' flight vehicles has shown to be unreliable in propellant tank pressure regulation. The issue being that mechanical regulators, while affordable, easy to operate, and fairly easily implemented into any system, are not very reliable or very robust. A potential solution to the mechanical regulator issue is active control pressure regulators. These are regulators that are electronically actuated using data collected across the feed system to actively modify the flow of pressure and gas into the propellant tank to accurately regulate it. So the objective of this project was to design, develop, and build an electronic pressure regulator and implement it into the team's test stand and flight vehicle architecture for future engines and projects to ensure that pressure regulation is not an issue in the future, especially as the team moves towards higher and higher complexity liquid fueled rocket vehicles. Moving into the conceptual designs, there are two very common pressure regulation methods for electronic pressure regulators. There's bang bang and there's servo actuated. First, we'll cover bang bang. Bang bang is the use of a solenoid valve most commonly, which has an open and closed state, and the system is simply switching that valve from open to closed and, shall we say, ping-ponging the propellant tank pressure. The other is servo actuated ball valves. Now, this is where you take a servo motor, link it to a ball valve, and then vary the open area fraction of that ball valve throughout test operation. We ultimately moved forward with the servo actuated method because we had seen other collegiate level teams were able to successfully execute on this method, and because it is a slightly more affordable and accessible design option, but provides better reliability and accuracy throughout test operation. The final design is a directly linked electronic servo driving a 1/8 inch ball valve, and this is going to be operated by the PID loop which we developed inside of Simulink. So we took Simulink and used it to create a high fidelity model of the feed system in operation. We're able to identify transfer functions for how the system operated and then create tuned PID controllers. So where are we at as of this filming? Well, as with any project, there have been delays and problems along the way. The first major issue was a setback we had in January where an engine was actually destroyed during a hot fire test. This pulled the attention of most of the rocket team, including myself, away from developing the regulator and trying to correct issues with the engine. The other major issue we had was with supply chain limitations, namely around the computer system that is going to operate the pressure regulator. So, as of this filming, the entire simulation is complete, as is the mechanical design of the regulators, and fabrication is in progress, with plans to test over the coming weeks before graduation. Some of the things we learned from this project were both in the technical and in the management realm. In the technical realm, we gained a massive amount of experience with MATLAB Simulink and with control theory. From a management side, this project was an excellent example of how unforeseen delays cause big delays when they're not preemptively accounted for. So at this point, the project is about 4 weeks behind the schedule that was originally planned in the fall of last year. However, there's been substantial progress on the simulation and design fronts, and there's still time to begin the testing phase and validation. The best thing about doing this project on the rocket team is that when the graduating seniors depart, there are more members that are ready to pick it up and carry on the work.